Hello everyone. I was asked to provide some more information about the configuration of the buttons I use in the Commander, and I have also a few tips and tricks for digital modes, especially for JT65 and JT9. So let's start with the buttons, power on, power off features, setting the power, and the power slider. So first of all, a big thank you to Dave AA6YQ for actually pointing me towards a perfect solution how to update the slider when I click the power buttons. So as you can see, the slider is getting updated right now. Yes, it helps to read the manual, hands down. So Dave, thank you very much. Great help, and I really appreciate that. So let's start with the configuration of the buttons. As I mentioned earlier, the buttons, you enable them right here in the configuration, user-defined controls. This is this section of the screen. We enable that. To set the button configuration, you right-click on it. That brings up the configuration. As you can see, I'm again using remote desktop from a Mac to a Windows machine. It doesn't really matter. Okay. This is the command FE, FE, FE. There is a lot of those hexadecimal digits, and then the rest of the command. So the actual command, individual command, is just this bit. The FE is basically a marker, so the radio is turned off. It's not listening for the commands all the time. So this is just a signal to the radio that when it sees FE, FE, and it checks at periods of time, it will know that there is a command coming. I have the commands actually explained right here in a better way. So for the start, you just add more, as a preamble, you add more FE, FE bytes to tell the radio that there is a command coming. For the power off command, as you can see, the radio is on, so you just send FE, FE. This is individual command for the radio in CIF format, and this is all documented in the full documentation, which is on a CD. Right, so going back to the commands. The commands are FE, FE for the radio on. 94 is the CIF address of the radio. 0E, then 1801 and 1800 for off. 18 is the command number. 01 is the first parameter, means turn radio on. 00 turn radio off. FD is just closing the command. I've added spaces here. You don't normally put those spaces. They are just for readability, so it's easier for us to explain. And for RF power settings change, it's the same format, FEFE 940E, 140A. So 14 is the command number, 0A is the sub-command number, and the parameter is between 0000 to 0255, which is basically the RF power output. 255 equals 100%, 00 is 0%. Of course, that gives basically roughly 2.55 per 1% of the power output. It doesn't work exactly with rounding up or rounding down, so you will see in the configuration I have that 5 watts is, for example, instead of 25 points, I gave it 26, rounded it up. So that's 10 watts. So that's how it goes. Okay, so going back to the buttons, the power on button is configured with a preamble of basically trial and error. I just copied and pasted a bunch of them. The higher the speed of the serial port, so this is 9600. If you go with the higher speeds, you may need well in excess of 100 of those FE pairs. And means basically for Commander that this is the end of the command being sent to the radio. Radio off, I've already shown you. This is go 2 watts, and this is FE, FE. This is the command, so roughly 3 per point, 6. That's what it's setting. And as you can see, I can turn this one on. If I do run, the power gets updated. One of the things that this is exactly the part that Dave has pointed out. So we have 4 sliders, 1, 2, 3, 4. When we change to alternatives, we have more sliders, so there's a slider 9 and so on. We can update them using this command, slider, the slider number, and the value to be shown. I give the value 6 here, and it recalculates for the display, and this is exactly what it should do on its own. So as you can see, the buttons, when I press the buttons, I even have the tooltips, I think. When I press the buttons, the radio updates and the slider updates as well, so I can very quickly, I can actually see what is being set. To update the slider configuration, this is you double click on the title, lower bound, higher bound, so this is basically what parameters can be provided. Small step, as I mentioned earlier, this is click on the arrow. Big step is when you click right here on the slider, in the middle of a slider. This is the text that will be put out on the label, and 100 here means that it has to be rounded up. So basically it has to be recalculated, rescaled down to 100, so between 0 and 100. So I can actually change that to percent, and that will be 10% power or 10 watts, however you look at it. I prefer it just displayed this way. The command, as I said, is right here, A0, and the D3 is the value of the slider, as I said, substituted in here. So that's how it works. One interesting thing about the slider, which I didn't mention earlier, so I've set a quick jump, you know, roughly 5 watts, roughly, but what happens when you basically just press this one? It will go one by one, right? So if I go faster, as you can see, we are 42 watts here and the radio is behind. That's because of the port speed. So the radio will get all of the commands as they go in order. It's not, well, if you go with a higher speed, the delay will not be that massive. You can see it's always lagging a bit behind, which is, well, it is okay, okay? It's just basically how you want to set it up. Increase the speed, that issue should basically disappear, at least to a degree. I have continuous interrogation of the radio setup. Maybe I should play a bit with the timings, but to be fair, it's okay for me. I'm mostly using 5-watt steps if I need it, or basically the buttons, which I predefined for quick access. On remaining sliders, I just gave the text not used for us. So another interesting thing that you will see here is that on the receive side in the waterfall, I have basically something that looks like a massive noise right here. There is something in here and also something in here. The radio is currently running with the default settings. So one of the default settings is, if you look into the filter width, that's a receive filter. So you have separate filters for data and separate filter for, so you see this is, okay, filter 2. Okay, the filter width is currently 1.2, and that's for the data mode. If we turn off the data, we are at 3. So let's go back to the data and set the filter. Hold it for a bit longer, and you can see, oh sorry, we are in the wrong mode. Let's go to data mode, and the filter width is 1.2. Those markers on the screen here, those areas, they come pretty much from the filter settings. So what I found, what works quite well, is changing the filter bandwidth to maximum 3.6. For the receive, those are digital modes, so I'm not really fussed about it. And you will see immediately, right now, that with a filter width 3.6, the whole area on the left here disappears. This stripe and this one disappears as well, and I can hear quite a lot at this stage. Okay, let's do one more trick. So at the moment, as you can see, I have the waterfall from between 0 and give or take 2.75 kilohertz up from the tuned frequency. Now in this one, it's worth actually increasing. So at the moment I don't see too much of JT9 transmissions. What I can do, if I do more bins per pixel, that actually can take me up to 4 kilohertz, give or take. And with 3.6 filter, as you can see, we have a 3.6 filter, so it's roughly, yeah, the 3.6 is roughly here, and it's correct. There is nothing there. Well, except there is a signal right now, which seems to be quite strong. But yeah, you can see the shape of the filter. So if we go, for example, to 3 kilohertz right now, the characteristics has moved slightly, so we should see the gap moving towards this region. Oh, and we see on the right hand side, it looks like a signal. It's not a signal, it's literally the shape of the filter. Also, you will be able to see between the sharp edge and the soft edge, the shape of the filter you will see here on the plot. So okay, let's go soft. Oops, oh, my bad. 7.6. We go in 7.6, and actually, yeah, a good lesson. Dial lock. Yeah, bandwidth. Let's go 3.6. Okay, here we are. If you want to go to default, you just press the default button and it will revert back. Okay, here we are. So I found the best results for the receive are right here. Now there is one trick with the filter width. Your filter width for the receive is at the moment 3.6, so roughly here. Maybe I overshot it a bit, so yeah, this makes sense. So up to 2.5 kilohertz from the frequency we have JT65, over here JT9 signals. The trick is, what is our transmit bandwidth? Because if we try to transmitting here being tuned to 14076, well, will the signal actually go out? So the short answer is no, it will not. So I tried and didn't get much luck with that, even on JT9. So what we are going to do now, if you want to change the transmit bandwidth, but basically you just need to be aware of it. There's not that much you can change. So tone control, TX, SSB, and the wide filter is 2900, from 100 to 2900, medium 300 to 2700, and 500 to 2500. So there's not that much that we can do, because we cannot increase this one anymore. So be it. That means nothing more for us. That basically, if we want to transmit JT9, because we will see stations transmitting in this section, if you want to transmit JT9, you have to either change the mode in here to JT9, which what it does exactly, if you look at the frequency readout below, it just moves us a small QSY 2 kilohertz up, and that's where we are. That will fall within our filter. But so roughly till 2700, 2800, you should be able to actually work those stations. 2900 is like the borderline. Anything here, it's actually a problem at this stage. Also, another issue I found was that when the band was opening and the conditions were really, really good, the problem I had was that the waterfall was full, plenty of signals, strong signals, even nearby signals, and I couldn't decode anything. So it depends on the application. They will behave differently. WSJTX I found to be quite sensitive to very strong signals, and sometimes it just blocks, it doesn't decode correctly. The JT65, the HB9 version, seems much more resilient in this respect, but it doesn't do JT9, so one or the other. I decided to stick with this one. What is the trick? If you remember from one of my past videos, in PSK31, WinRablo was showing overload and not decoding. So what I found actually, what helps with improving the decode rate in connectors, that's ACC USB AF output. So AF output, if we just lower it down, I found that actually around 10% I can have very strong nearby signals, and it will still decode pretty much everything at this stage. So okay, there should be some transmission here, but there's not that much on the waterfall either. There are some JT9 signals. Oh no, there is something actually going in there. So yes, so this is how it works. So my suggestion, if you run into this trouble, into this problem, lower down the AF gain from the radio to the computer. That helped with the signal quality slightly, it seems, and the software started decoding much better. The output, the AF gain for from computer to the radio, and that is, where do we have this one? USB modulation level. So adjust that to get the ALC readouts correctly, as I mentioned earlier. So yes, this is roughly everything for this installment. If you have any questions, any suggestions, please do let me know, and I'll try to well, at least test the issues you are experiencing, see if I can replicate them. It's a new radio, so yes, we learn. It's a learning curve. Okay, that's it. I hope it was useful. Take care, guys. See you next time.